Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to learn what is gear train, what are the types of gear train. So, a gear train is the combination of gears is used to transmit motion or torque from one shaft to another. But it is very important that this gear train is used for decreasing or large reduction of velocity ratio. If you want to reduce larger reduction of velocity or speed reduction within a small space, these gear trains are used. So there are different types of transmission instruments or transmission components are available. But the point is that there is one more drives that is called power transmission drives, that is by belt drives. Belted drives. If you want to transmit torque for larger distances, these belt drives are used. For small distances or direct contact, if you want to use direct gear drives are used. Gear drives. So these gear drives are transmits torque by direct contact. By direct contact. But whereas belt drives are used by indirect contact, means through belts. Through belts, torque will be transmitted from one pulley to another pulley through belt drives. Again, in belt drive, there are two types of belt drives. Number one, open belt drive, and another one is closed belt drive or crossed belt drive. Now here, this gear train is the combination of number of gears within a small space. So there are four types of gear trains. Number one, simple gear train. Two is compound gear train. Third one is reverted gear train. And fourth one, final one is epicyclic gear train or planetary gear train. So what is a simple gear train? So a simple gear train is a series of gears are connected, are capable of receiving and transmitting motion from one gear to another, is called simple gear train. In this gear, all the gear axes remain fixed relative to the frame, and each gear is on a separate shaft. So there are how many shafts are here? There are 5 shafts, each gear having separate shaft, and suppose it is the driver gear, it is a driver, and the fifth one is the follower output. In between gears are there, those are called intermediate gears. Now here, a series of gears means number of gears. That's why this complete gears are known as the gear train. It is a simple gear train. So we can observe the following in simple gear train. So two external gears of a pair always move in opposite directions. If we consider the 1 and 2, the one is the driver and second gear is the follower in this. If we consider the combination 2 and 3, 2 is the driver for 3 and 3 is the follower for 2. And 3 and 4, 3 is the driver for 4 relation to 4 and 4 is the follower for 3. And 4 and 5 combination, the 4 is the driver and 5 is the follower. In complete overall series of gear train, in this train, number one is the driver and final one is the follower. Now, in this 1 and 2 combination, if one rotates, here one is rotating in counterclockwise direction, gear 1 is rotating in counterclockwise direction, whereas gear 2 in opposite to counterclockwise, that is clockwise direction. It is in clockwise, gear 3 is in counterclockwise. Gear 3 is in counterclockwise, gear 4 becomes clockwise. If gear 4 is in clockwise, finally gear 5 is in counterclockwise. So clockwise, counterclockwise starting and finally it is ended with counterclockwise. So point is that, the observation is that the two gears doesn't rotate when in contact each other, it will rotate in opposite direction. And next, all odd number of gears in this gear train are moved in one direction and all even numbers gears in opposite direction. So here what are the odd numbers of gears are? The 1, 3 and 5 are having in counterclockwise, whereas 2 and 4 in clockwise direction. Now what is the speed ratio? The ratio of the speed of driving to that of the driven shaft. The speed of the driving to the driven is known as the speed ratio. Okay, and it is negative when the input and output gears rotate in the opposite direction. So, and if it is positive when the both gears rotate in the same direction, then it is positive. It is positive when driver and follower moves in the same direction, rotates in the same direction. If driver and follower in opposite direction, then it is negative. Now, the reverse of the speed ratio is known as the train value or gear train. So, for the gear train, train value or gear train of the train value, the train value of the gear train, that equal to 1 by speed ratio. So that means train value equal to the follower speed by driver speed, NF by ND. That NF by ND that equal to TD by TF, the number of teeth on the driver by the number of teeth on the follower. It is nothing but velocity ratio. Velocity ratio is the ratio of the follower to the driver. Now here train value we will consider while solving the problem, that is NF by ND equal to TD by TF. Next, all the gears here in this figure can be in a straight line or arranged in zigzag manner. Okay, and one more thing, here the simple gear train, we are considering about the number of gear trains fixed. In the simple gear train, here we have shown that worm gears, and it can also be bevel gears in a gear train. So where T is the number of teeth on a gear and N equal to speed of gears in RPM. Now the reverse of speed ratio is known as train value. That is 1 by speed ratio equal to train value. What is the speed ratio? Speed ratio equal to speed of the driver by the speed of the follower. What is the train value? It is the reverse of the speed ratio, that is the follower speed over the driver speed, that is NF by ND. So here in this case, it can be a straight line, but it is in zigzag manner. It can also be connected on a straight line, means one after another in series. That is what we can observe from this figure, from this simple gear train. Now if you want to find out the train value or the speed and the speed ratios, the speed ratio we are following here, it is the train value. Consider 1 and 2 gears, that is N2 by N1 equal to T1 by T2. That is a speed, that is a train value from the 1 and 2. Then consider 2 and 3. Then which gear train is the follower? That is N3 by N2. N3 by N2 equal to T2 by T3. That is the combination. This is the combination 1 and it is combination 2 for that. Next, consider 3 and 4. 4 is the follower, 3 is the driver. The speed of the follower over the speed of the driver equal to T3 by T4. That is N4 by N3 equal to T3 by T4. And finally, combination 4 and 5. Here 4 is the driver, 5 is the follower. The speed of the follower by speed of the driver, that is N5 by N4 equal to T4 by T5. The product of all these trains, that is N2 by N1 times N3 by N2 and N4 by N3 and N5 by N4. If we cancel it, finally it comes N5 by N1. So this N5 by N1 equal to, directly if we consider N5 by 1, N5 by N1 equal to T1 by T5 mentioned. But the point is that, yes, if we consider T2, T3, T3, T4, T4, then finally N5 by N1 equal to T1 by T5. That is the train value of this simple gear train. That means what is the T1? The number of teeth on a driving gear by the number of teeth on a driven gear. Here 5 gear is the follower or driven. So N5 by N1, that is N5 by N1 equal to T1 by T5. That is speed of the follower by speed of the driver equal to the number of teeth on the driver by number of teeth on driven gear. That is N5 by N1 equal to T1 by T5. So this is the train value. What is the speed ratio? That is 1 by train value. That is inverse of this train value. That is N1 by N5 equal to T5 by T1. But in these problems, we will consider mostly this train value will consider while doing analysis or calculating the speeds of various gears or the number of teeth of various gears we want to calculate. Then we use this train value formula, that is N5 with the speed of follower by speed of driver equal to the number of teeth on driver over the number of teeth follower. That is the first type of gear train. So one thing is that from this equation, the obtained equation, that is N5 by N1 equal to T1 by T5, we can understand that there is no intermediate gears here. 2, 3, 4 is not affecting. That means N5 by N1 equal to T1 by T5. In this, the intermediate gears are gear 2, gear 3, gear 4 have no effect on the speed ratio. That's why these 2, 3, 4 gears are known as idlers. 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 Okay. This is about the description of simple gear train. Coming to second type of gear train, that is compound gear train. In this compound gear train, what is the compound gear train? In this compound gear train, there will be more than one gear will be fixed on the same shaft. The 2 and 3 is on the same shaft. That's why it is called a compound gear train. These 2, 3 gears, gear 2 and gear 3, gear 4 and gear 5 are mounted on a same shaft. 2 and 3 mounted on one shaft, 4 and 5 mounted on another shaft. And gear 1 and gear 6 are separated shafts. Now here, what is the description of this compound gear train? When series of gears are connected in such a way that the 2 or more gears rotate about the axis with the same angular velocity. That is, it is known as a compound gear train. Now the angular velocity of gear 2 and gear 3, the speed is the same, 2 and 3. Omega 2 or N2 equal to N3. Why? Because it is fixed on a same shaft. And 4 and 5 also same. It is fixed on a same shaft. So one more thing is that in this type, some of the intermediate shafts, what are the other than input and output shafts, carry more than one gear. The intermediate shafts are here. This 2 and 3, one of the intermediate, and 4 and 5. These are the intermediate shafts are having, suppose shaft is this P and shaft is Q. This shaft P and shaft Q are having more than one gear. What is more than one gear? 2 and 3 are mounted on the same shaft P, and Q is mounted on the same shaft Q. 4 and 5 are mounted on the same shaft Q. Now, for calculating the train value of the compound gear train, now let us begin. The combination, one is connected with, one is measured with 2 gear 1 is measured with gear 2. If gear 1 is the driver and gear 2 is the follower, then N2 by N1 equal to T1 by T2. Next, if we consider 4 and 3, N4 by N3 equal to T3 by T4. Why we consider here? Why not gear 2? Because gear 3 and 2 are mounted on the same shaft. So gear 3 is in contact with gear 4. That the speed of the follower gear by speed of the driver gear equal to, that is T3 by T4. That is N4 by N3 equal to T3 by T4. Now consider 3 and 1 and 2 combined, 3 and 4 in contact. Now on the same shaft, 5 is in contact with the 6. That 5 is the gear, is the driver, 6 is the follower. Then N6 by N5 equal to T5 by T6. Now the combination, if we the product of these gears, that is N2 by N1 times, N4 by N3 times, N6 by N5 equal to T1 by T2 into T3 by T4 into T5 by T6. Very important is that here, this N2 and N3 are cancelled. Why here? It is mounted on the same shaft. The speed of the gear 2 equal to speed of the gear 3. That is N2 equal to N3. Next is N4 equal to 4 and 5 mounted on the same shaft. The speed of gear 4 equal to speed of gear 5. So N2 and N4. Now, what is N6 by N1 equal to? But the teeth are not same. That's why not cancelled. Then it is the combination of product of T1, T3, T4, T1, T3, T5. The product of driver gear teeth, that is T1, T3, T5 by the product of driven, that is T2, T4, T6. So train value N6 by N1 equal to T1, T3, T5 by T2, T4, T6. That means the product of number of teeth on driving gears by product of number of teeth on driven gears. That is the train value. So here once again, there are compound. What is the difference between simple gear train and compound gear train? In simple gear train, each gear is mounted on each separated shaft. Whereas in compound gear train, there will be intermediate shafts. On that intermediate shaft, there are more than one gear is mounted. That is the main thing. That is the main difference between simple gear train and compound gear train. And one more important difference is that larger speed reduction can be taken place in the same space in comparison to simple gear train. In compound gear train, the larger speed reduction can be in a limited space, in the given space. So whereas in simple gear train, more space is required. Okay, and these are the important differences between simple gear train and compound gear train. The third gear train is known as reverted gear train. The speciality of reverted gear train is that the axis of input gear and the output gear axis are coincidental. That is the reverted gear train novelty in comparison to compound and simple gear train. In compound gear train, all axes of the gears are parallel. Now here in reverted gear train, the axis of the first and the last wheels of a compound gear are coincide. It is called a reverted gear train. Then only it is called a reverted. If gear 1 and gear 2 rotate in opposite direction, but 2 and 3 mounted on the same shaft, and 3 and 4, the axis of gear 4 and the gear 1 are coincidental. Coincide. Okay. Now, one more thing is that this type of gears, gear train, reverted gear train, are used in clocks and also in simple lathes. For what? To give, in the case of simple gear, where in case of lathe machines, where back gear is used to give a slow speed to the chuck. So in the gearbox it is used to give slow speed to the chuck. This reverted gear train are used. Now what is the train value? The train value N4 by N1 equal to, the train value N4 by N1 equal to, that is N4 by N3 and N2 by N1. Now if you substitute what is N4 by N3 in the place of N4 by N3, that is T3 by T4, N2 by N1, that is T1 by T2. So why here N2, the product N2, N3, it is on the same shaft, it is equal speed. So N4 by N1 equal to T3 by T4 by T3 by T4, T3 by T4 times T1 by T2. So this is that means T1, T3. What is the T1, T3 are? The product of gears, that is called driver gears. The product of number of teeth on the driving gears, and T2, T4 are follower gears or driven gears. So product of number of teeth on driven gears are follower gears. So driving gears product number of teeth by follower gears. So this is another type of gear train, and the train value for this N4 by N1 equal to T1, T3 by T2 times T4. One more important is that here the special novelty in comparison to compound gear train is that the sum of the radius of, that is T1 plus T2, that is R1 plus R2, R1 plus R2 equal to R3 plus R4 or R4 plus R3. What is R here? The pitch circle radius of gear 1 or pitch circle radii of gear 1, gear 2, gear 3 and gear 4. The total pitch circle of gear 1 and gear 2, because the length of pitch circle is the same. That's why the pitch circle radius of gear 1 plus gear 2 equal to gear 3 plus gear 4. It is very important. From these conditions, we can calculate the required speeds of the gears and the required pitch circle radius, also required number of teeth on follower and driving gears. The fourth one is called epicyclic gear train or planetary gear train. So it is a very important gear train in comparison to other gears. Here, speciality of the gear train is that one is like a sun and a planet gear train. When sun is fixed, when sun is on planet, it will rotate planetary. This P gear rotate on the circumference of S gear. That's why S and P, sun and planet gear train, it is also. Here the axis of sun and P, S and P gears are different. It is under movable. Okay, it is completely moves. The axis of both the gears will rotate. Okay, it is not fixed. Now, a gear train which is having a relative motion of axis is called as planetary or epicyclic gear train, or simply known as epicyclic gear or train, epicyclic train. Now, in this epicyclic train, at least one of the axes will be under moving condition relative to the frame. Okay. Now here we are considering the two gears wheels. One is S, another one is P. The axis of these two gears are connected by arm. That is A arm. It is connected with arm A. If the arm is fixed, the S and P combination is a simple gear train. They constitute a simple train or simple gear or simple gear train. If the S is, however, if the S wheel S, that is sun wheel, is fixed, the arm can rotate about the axis of S. The arm will rotate. and the P would also move around S. It will move. If S is fixed and rotating, then what happens? This P will move like a planet. So it is a epicyclic train. Now we can see in a simple, okay, we can see here one more thing. When arm is fixed, the epicyclic train becomes the simple train. When S is fixed, arm is rotating. The arm rotating means that it also takes P. The P will rotate like a planet around the sun. That's why it is also known as sun and planet gear train, or simply epicyclic train. So, and for calculating the speeds of analysis, for calculating the speed of the planet, that is P gear and S gear, we have to use, there are two types of methods are there. Velocity ratios or speed of the different. So what is that methodology is that? One is the tabular method, another one is relative velocity method. One is the tabular method, another one is relative velocity method. So generally we follow mostly this tabular method is the most applicable and easy to solve the speeds of various gears in a epicyclic gear train. Now let us see here how the simple gear train works. In the simple gear train, it is the A is the driver and C is the follower or driven and B is the idler. So the function of the simple gear train. But we can see here the A gear is rotating in counterclockwise direction, B gear is rotating in clockwise. When B is in clockwise, C becomes counterclockwise. So thus, in the simple gear train, all the wheels will rotate when in contact in opposite direction. It is not in the same rotation. The next gear train is the compound gear train. In this compound gear train, here we can see the two gears are fixed. Gear B and gear C are fixed on single shaft. The speed of the gear B equal to speed of the gear C. But not TB is not equal to TC. The number of teeth on the gear B is not equal to number of teeth on the gear C. Okay. And the gear A is in contact, is meshed with gear B. And not gear B is in touch with gear D, but gear C is in contact with gear D. So these gear trains are used for larger speed reduction purposes in a given space. And the space occupying by compound gear train is low in comparison to simple gear train. And here each gear is not fixed, mounted in different shafts. Okay, whereas in simple gear train, each gear is mounted in separate shaft. Whereas in compound gear train, there are two gears or more than one gear is there on the same shaft. So this is about compound gear train. Next, this is reverted gear train. We can see in this figure in the reverted gear train, the axis here, it is gear 1, gear 2, gear 3 and gear 4. The gear 1 is the input gear and gear 4 is the output gear, final gear. But the axes are coincidental of the gear 1 and gear 1 and gear 4. Axes are coincide. Now here, and again 2 and 3 are mounted on the same shaft. So reverted gear train is also called as a compound gear train. But compounded gear train but is not a reverted gear train. So the compound wheels, why compound here? There are more than 2 gears are mounted on a simple same shaft. That's why it is a compound gear. And at the same time, here in this gear 4, axis of gear 4 and gear 1 are coincidental. That's why it is a reverted gear train. If you look back compound gear train, the output gear, final gear is the gear D and it is gear A. The gear A and gear D axes are parallel but not coincidental. That's why a compound gear train is not a reverted gear train, but a reverted gear train is a compound gear train. Okay, because the by principle that the two gear, more than one gear is mounted on the same shaft. Coming to the epicyclic gear train, in this we can see various types of epicyclic gear trains are there. Here it is a sun and planet. All are sun and planet gear trains here, but it is 1 and 2. Only 2 gears are there. Here we can see it is external contact. But here the combination is that there are 4 gears are there. One is annulus wheel. This is annulus wheel. Is gear 1, 2, 3 and it is 4. Now gear 1 and annulus wheel A, both are in the same direction. All gear 1, gear 2, gear 3 are in the same direction of annulus wheel. Whereas gear 4, it is in opposite direction to annulus wheel, gear 1, gear 2 and gear 3. Okay, and it is another combination. How many gears are there? 5, 6, 7, 8 gears. In that one is annulus wheel, and we can see how these gears are rotating. But the torque is transmitted from annulus wheel to sun wheel or center wheel through small pinions, small gears. But the rotation of, you can see annulus wheel rotation and it is gear 1 and gear 2 are same. And also how it is transmitting the same rotational motion. If you want to require, or the requirement is that the rotation of the annulus wheel should be same as the rotation of the center wheel, then we have to go for this third type. So the rotation, it is clockwise and also clockwise. So this is another type of category, how the annulus wheels, how the planet, sun and planet gear, the epicyclic gear train is mounted in a mechanism. Okay. Now here, one thing is that we can observe in comparison to other types of epicyclic gear trains. Here the epicyclic gear trains are fixed and rotating. But in this case, the final type, fourth type is that these are movable. The axes are movable. All this. But the annulus wheel is fixed here. The annulus is fixed. In this case, annulus are moving condition. Here it is fixed. When annulus wheel is fixed and the remaining planet wheels are rotating under movable. The axes are under moving condition. So in this session, we learned classification of gear trains. The first classification is simple gear train. Second classification is compound gear train. Third type is reverted gear train. And final one is epicyclic gear train. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.